There is no national electrical code requirement mandating ground fault circuit interrupter, or GFCI, protection for receptacles in non-dwelling units located within 6 feet of a water source in the 1996, 1999, or 2002 editions of the NEC. The requirement for GFCI protection for receptacles within 6 feet of a water source in non-dwelling units first appeared in the 2005 NEC. Therefore, if the current project is under the 99 code, GFCI protection is not required for receptacles within 6 feet of a water source in non-dwelling units. Article 100 of the National Electrical Code defines a dwelling unit as one or more rooms functioning as a single housekeeping unit with provisions for living, sleeping, cooking, and sanitation. Places such as hospitals, office buildings, stores, warehouses, and the like are not dwelling units. Ground fault circuit interrupter protection is crucial for enhancing electrical safety, especially in areas where the risk of electric shock is elevated due to the presence of water. A ground fault occurs when there is an unintended electrical path between a source of current and ground. This can happen when insulation fails or when water creates a conductive path. GFCIs are designed to detect these ground faults and quickly interrupt the circuit, preventing serious injury or death. The way a GFCI works is by monitoring the current flowing into and out of a circuit. In a properly functioning circuit, the current flowing into the circuit should equal the current flowing out. If there is a difference, it indicates that some current is leaking to ground, signaling a ground fault. When a GFCI detects this imbalance, typically a very small amount such as 5 mA, it trips the circuit within a fraction of a second, cutting off the power and preventing electrical shock. In dwelling units, the NEC has long required GFCI protection in areas where water is commonly present, such as bathrooms, kitchens, and outdoor locations. This is because these are the areas where people are most likely to come into contact with water while using electrical appliances or equipment. The introduction of GFCI requirements for non-dwelling units in the 2005 NEC recognized that the risk of electrical shock near water sources is not limited to residential settings. Commercial kitchens, laboratories, and industrial facilities also present environments where water and electricity can create hazardous conditions. The specific NEC section that introduced this requirement is 210.8b, which covers GFCI protection for personnel in other than dwelling units. In the 2005 NEC, this section required GFCI protection for 125 volt, 15 amp and 20 amp receptacles located in certain areas, including bathrooms, rooftops, and kitchens. Subsequent editions of the NEC have expanded the requirements for GFCI protection in non-dwelling units. The 2008 NEC added specific requirements for GFCI protection in locations such as garages, service bays, and areas with sinks where water is likely to be present. The 2011 NEC further expanded the requirements to include laundry areas, indoor wet locations, and locker rooms with showering facilities. The 2014 NEC introduced requirements for GFCI protection for dishwashers in commercial kitchens and for receptacles within 6 feet of sinks in commercial and industrial locations. The 2017 NEC continued to refine these requirements, adding provisions for GFCI protection for specific types of equipment and in specific locations within non-dwelling units. The 2020 NEC includes comprehensive requirements for GFCI protection in a wide range of non-dwelling unit applications. These requirements are designed to ensure that workers and other occupants are protected from electrical shock hazards in commercial and industrial settings. It is important to consult the specific edition of the NEC that is in effect in the jurisdiction where the project is located to determine the exact requirements for GFCI protection. The NEC is updated every 3 years, and each edition may include changes or additions to the GFCI requirements. In addition to the NEC requirements, local codes or regulations may also impose additional requirements for GFCI protection. It is essential to check with the local electrical inspector or building department to ensure compliance with all applicable codes and regulations. When installing GFCI protection, it is important to follow the manufacturer's instructions carefully. GFCIs must be installed correctly to function properly and provide the intended level of protection. It is also important to test GFCIs regularly to ensure that they are working correctly. GFCIs should be tested monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. There are two main types of GFCIs that are commonly used: receptacle type GFCIs and circuit breaker type GFCIs. Receptacle type GFCIs are installed in place of standard receptacles and provide GFCI protection for that specific outlet. Circuit breaker type GFCIs are installed in the electrical panel and provide GFCI protection for the entire circuit. The choice between receptacle type GFCIs and circuit breaker type GFCIs depends on the specific application and the desired level of protection. Receptacle type GFCIs are often used in areas where only a few outlets need GFCI protection, while circuit breaker type GFCIs are used when an entire circuit needs to be protected. In some cases, both receptacle type GFCIs and circuit breaker type GFCIs may be used in the same installation to provide comprehensive GFCI protection. For example, a circuit breaker type GFCI may be used to protect the entire bathroom circuit, while receptacle type GFCIs are used to protect individual outlets near sinks or showers. When selecting GFCIs, it is important to choose devices that are listed by a recognized testing laboratory such as Underwriters Laboratories, or AL. Listed GFCIs have been tested and certified to meet industry standards for safety and performance. It is also important to choose GFCIs that are rated for the appropriate voltage and current for the application. GFCIs are available in a variety of voltage and current ratings, and it is essential to select a device that is compatible with the electrical system. In addition to providing protection against electric shock, GFCIs can also help to prevent fires caused by ground faults. Ground faults can generate heat, which can ignite nearby combustible materials. GFCIs can interrupt the circuit quickly enough to prevent the heat from building up to dangerous levels, reducing the risk of fire. GFCIs are an important safety device that can help to protect people and property from electrical hazards. By understanding the NEC requirements for GFCI protection and following proper installation and testing procedures, it is possible to create a safer electrical environment in both dwelling and non-dwelling units. GFCI protection is a critical component of any electrical safety program. GFCIs are relatively inexpensive and easy to install, making them a cost-effective way to reduce the risk of electrical shock and fire. In addition to the specific requirements for GFCI protection near water sources, the NEC also includes general requirements for GFCI protection in other areas, such as bathrooms, kitchens, and outdoor locations. These requirements are designed to provide a comprehensive level of protection against electrical hazards in a variety of settings. It is important to be aware of all the NEC requirements for GFCI protection and to ensure that all electrical installations comply with these requirements. Compliance with the NEC is essential for ensuring the safety of people and property. The NEC is a comprehensive set of standards that covers all aspects of electrical installations, from wiring methods to overcurrent protection. By following the NEC, it is possible to create electrical systems that are safe, reliable, and efficient. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest edition of the NEC and to ensure that all electrical work complies with the current requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and from other sources. The NFPA also offers training and certification programs for electricians and other electrical professionals. These programs can help to ensure that electrical workers have the knowledge and skills necessary to perform their job safely and effectively. In addition to the NEC, there are other standards and guidelines that may be relevant to electrical safety. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be aware of these other standards and guidelines and to follow them when appropriate. Electrical safety is a shared responsibility. Electricians, contractors, building owners, and occupants all have a role to play in ensuring that electrical systems are safe. By working together, it is possible to create a safer electrical environment for everyone. Ground fault circuits interrupters are essential safety devices that protect against electrical shock. They work by monitoring the current flowing through a circuit and quickly cutting off the power if a ground fault is detected. Ground faults occur when electricity flows through an unintended path, such as through a person's body. This can happen if someone touches a live wire or if there is a short circuit in an appliance. GFCIs are designed to detect even small ground faults and to trip the circuit within milliseconds, preventing serious injury or death. There are two main types of GFCIs, receptacle type and circuit breaker type. Receptacle type GFCIs are installed in place of standard electrical outlets and provide protection only for that outlet. Circuit breaker type GFCIs are installed in the electrical panel and provide protection for the entire circuit. GFCIs are required in many areas of homes and businesses, including bathrooms, kitchens, garages, and outdoor areas. The National Electrical Code, or NEC, specifies where GFCIs are required. It is important to follow the NEC requirements to ensure that electrical systems are safe. GFCI should be tested regularly to ensure that they are working properly. Most GFCIs have a test button that can be pressed to simulate a ground fault. When the test button is pressed, the GFCI should trip and cut off the power. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. GFCIs are an important part of any electrical safety plan. They can help to protect people from electrical shock and can even save lives. Understanding how GFCIs work and where they are required is essential for electrical safety. GFCI protection has evolved significantly over the years, driven by a greater understanding of electrical hazards and technological advancements. Early electrical systems lacked the sophisticated safety measures we have today, resulting in a higher incidence of electrical accidents. As awareness grew, so did the demand for better protection mechanisms. The introduction of GFCIs marked a major milestone in electrical safety. These devices were initially developed to protect people from electrical shock in damp or wet locations, where the risk of ground faults is higher. Early GFCIs were relatively bulky and expensive, limiting their widespread adoption. However, as technology improved, GFCIs became smaller, more affordable, and more reliable. The National Electrical Code played a crucial role in promoting the use of GFCIs. Over time, the NEC has expanded the requirements for GFCI protection to include more and more locations and applications. This has led to a significant reduction in electrical injuries and fatalities. Today, GFCIs are an integral part of modern electrical systems. They are widely used in homes, businesses, and industrial facilities to protect people from electrical shock. The technology behind GFCIs continues to evolve, with newer models offering improved performance and features. Some GFCIs, for example, now include self-testing capabilities that automatically check the device's functionality on a regular basis. The future of GFCI technology is likely to focus on further miniaturization, improved reliability, and enhanced features. As electrical systems become more complex, the need for effective ground fault protection will only increase. GFCIs will continue to play a vital role in ensuring electrical safety for years to come. The importance of proper installation and maintenance of GFCIs cannot be overstated. A properly installed GFCI will provide reliable protection against electrical shock. However, a poorly installed or maintained GFCI may not function as intended, leaving people vulnerable to injury. It is essential to follow the manufacturer's instructions carefully when installing GFCIs. This includes ensuring that the device is properly wired and grounded. GFCIs should also be tested regularly to verify that they are working correctly. The test button on the GFCI should be pressed at least once a month. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. GFCIs have a limited lifespan and may need to be replaced periodically. The lifespan of a GFCI depends on several factors, including the quality of the device and the environment in which it is installed. In general, GFCIs should be replaced every 10 to 15 years. It is also important to protect GFCIs from physical damage. GFCI should not be exposed to excessive moisture, dust, or vibration. Damaged GFCI should be replaced immediately. By following these simple guidelines, it is possible to ensure that GFCIs provide reliable protection against electrical shock for many years. Ground fault circuit interrupters are life-saving devices that protect against electrical shock. They are required in many areas of homes and businesses, and it is important to understand how they work and how to maintain them. GFCI protection is a critical component of electrical safety, and it should be taken seriously.